All right, so today we're reviewing measures of center, different ways that you can take data and measure it, kind of measure the center of the data. And this is all stuff that you've learned before. We'll focus a little bit more on analyzing it today than maybe you've done in the past. If you don't remember how to find the mean, median, and mode, on the second page of the notes, you've got some information there to kind of help remind you how to do it. There's an explanation of what the mean is. Remember, the mean is the average of the values in the set of data. So you add them all together and you divide by how many of that number there is. So you find the average. So another word for mean, you can put average there if you want. The median is the number in the middle. So you put them in order and you find the number in the middle. And that's another measure of the center because it's the middle number, right? The third one is the mode, and that's the number that shows up the most. So you just look at all the different numbers and see which one shows up the most. A lot of data sets don't have a mode because everything will only show up one time, and that's okay. It's okay to say that there is no mode. That is a perfectly acceptable answer. So if you need to review those concepts, there's some information there to do it. So find the mean, median, and mode of the student test scores. So example number 1 here. So to find the average or the mean, there's two different symbols that represent the mean. And maybe we should put these at the top, the mean or the average. One symbol is an X with a line over the top of it. And the other one, it kind of looks like a fancy U. Like when people write in cursive, it's that kind of sort of U shape. And those are different symbols that mean average. So I've got these test scores. To find the average, I add them together. So the average would equal 60 plus 80 plus 90 plus 60 plus 70, which is 360. And then you divide by how many scores you found. And there's 1, 2, 3, 4, 5. So 36 divided by 5 equals 72. So the average student score is 72. The median, if I put these in order, I've got 60, 60, there's 170, there's 180, there's 190. And if I work my way to the middle, then 70 would be the median. The median would be that 70 right there in the middle. Now mode, the number that shows up the most, is 60. It shows up twice. Now what happens if you add another test score? Now notice this score is 92. Now one thing to think about, when you add a number 92 that is higher than the average, that's going to make the average go up, right? Usually if you add in a new number and it's higher than the others, it pulls everything higher. Not necessarily the mode, but the other measures of center. So if I take that, let's see, the new average, we had 360 originally. Now I have to add 92 more. So that's going to be what, 452? And I'm going to divide that by 6. And that's going to give me 75.3. And that 3 looks like it repeats forever. So my average went up. It went up 3 points. And you guys know that. Like if you have an average score in a class and you do an assignment or a test or a quiz and you score higher than your average, then your class grade goes up. If you score lower, then it makes your grade go down. And this is the same idea. Adding in a number that's bigger is going to pull my average up. Now, as far as the median goes, my numbers are 60, 60, 70, 80, 90, and now 92. So when I start crossing them out, I end up with two numbers. 70 and 80 that are in the middle. So I just find what's in the middle of those two numbers. So in this case, the median is going to be 75 because 75 is in between 70 and 80. And then the mode, the number that shows up the most, is still the number 60. Okay? All right, example number 2. I wanted to look at this example because the kinds of numbers that we're using in number 2 are a little bit more difficult to work with because they're giving you the heights of basketball players. But the heights that it gives you are given in feet and inches. And so when you try to like add these together, a lot of people struggle when they add feet and inches, and they struggle with how to do that with decimals and different things. So the easiest way to do this is just to turn all the numbers into inches, okay? So 5 feet, 6 inches. Well, in 5 feet, 5 times 12, there's 60 inches. So that means that 5 foot 6 inches is the same thing as just saying 66 inches. 5 foot 10 is 60 plus 10. So that's going to be 70 inches. 5 foot 11 is going to be 71 inches. 5 foot 4 is going to be 64 inches. 6 foot is going to be 72 inches. 5 foot 10, we already did that one, right? Yeah, 70 inches and another 70 inch. Now, the reason I like doing that is now when I add them together, I'm just adding regular numbers. I'm not having to try to convert inches to decimals, which never goes very well because they're not, there's 12 inches in a foot, and dividing a number by 12 doesn't give you a nice response. So you add all of these together, and you get, what, 483? Let me use my correct symbol here. So the average is 483 divided by, there's 1, 2, 3, 4, 5, 6, 7 players. 483 divided by 7 is 69 inches, which is the equivalent of 5 feet and 9 inches tall, right? So the average player on this basketball team is 5 feet, 9 inches tall. What if you get a new basketball player on the team? He's 6 foot, 9 inches, and it wants me to find the new average. So that 6 foot, 9 inches is going to be the same as what, 72, so 81 inches. So if I do 483 plus that 81, then I get 560. Oh, I wrote 480. I'm like, wait a minute, that's 483. Okay, I wrote it wrong. I get 564. This time I'm going to divide that by 8, and I get, 70.5 inches, which is the same thing as, 5 feet and 10 and a half inches tall. So that would be my new average with that new player, which makes sense. The new player is taller than the rest of the players, and that's going to pull my average up. So it went up 1.5 inches just from one player, but he was quite a bit taller than everybody else, right? Okay, median. If I put these all in order, let's see. The shortest person is 5'4", and then I've got 5'6", and then I've got 5'10" 3 times. And then I've got a 5 foot, I've got a 5'11", and I've got a 6 foot, and then I have a 6'9" player. So if I work my way, but I guess the first time we can't include the 6'9", right? So if I work my way to the middle, 6 foot, 5'4", 5'6", 5'11", then my median is going to be 5 foot 10 inches. So my median height is 5 feet 10 inches, and my mode, the player that shows up, the height that shows up the most is 5 feet 10 inches also, okay? Now if I add in my new player, let's see if I can get rid of these without erasing too many numbers. If I add in my new player, then I've got this 6 foot 9 inch guy. So my median might change, it might not, I'm not sure. 5'10", 5'10", the number that's in the middle of those is still 5'10". So median is still 5 feet 10 inches, and the mode is still 5 feet 10 inches. So even though I added a new player, my median didn't change and my mode didn't change, but my average went up 1.5 inches, okay? Now, example number 3 is gonna kind of help us lead into some other lessons later on in the quarter. But I think it's a good example of why you shouldn't always trust the average or the mean, okay? So you've got all these different houses that sold, okay, or are getting sold in this small town. So you've got the different prices of these houses, and most of them are, what, you've got 123,000, 150,000, 90,000. There's one way down at 80,000. I don't think you could find a house in St. George for 80,000. And then you've got one that's $1,250,000. Now, the problem with these numbers, when I add them all together, I end up with $2 million, 120,000. And if I divide that by, what is there, 1, 2, 8, there's 8 houses for sale, then that tells me that the average home price is $265,000. But when I look at those houses, 123 isn't even half of that value. 150 is a little bit over half. 90,000, that's a third of the average. 137 is a little more than half. 80 is less than a third. 100 is a little bit more than a third. 1,250,000 is way bigger than the average, and 190,000 is lower than the average. So the problem with average, we can see in this example, this $1,250,000 house makes the average home price look really big, which might be a good thing, okay? If I was trying to convince someone to sell their house, right? If I was a realtor and I wanted someone to, hey, you really should sell your house right now. The average house is selling for $265,000. That would be very misleading because there's only one of these houses that sold for that much, and it sold for way more. The rest of them sold for way less than $265,000. So that might mislead someone into making a decision based on the average that they wouldn't make if they knew the individual values of the houses being sold. So as powerful as the average is, when you get these numbers, we call these outliers. When you get these outliers, it really messes up the average because it makes it way bigger or way smaller because of one value. If we got rid of this value, the average, I don't know what it would be. Let me see if we got rid of that one great big house that sold for a whole bunch, the average would be 124,000. So the average would be cut in half if we got rid of just one of those homes that got sold. So you got to be really careful when people give you averages. We're going to spend a whole day talking about that. That just because you see a good average doesn't mean that that's representing a good thing. That can be very, very misleading. Here's another example of why the average might be misleading. So here's a diagram of a household income in 2010, okay? So this is the average monthly household. I don't know where this diagram came from. I don't remember. I don't know if this is for the whole country or just certain parts of the country, but these values are how much money people make in a month. Now, when you look at this, it says that the average monthly income is $8,700. But when I look at this diagram, 8,700 is right about here on the graph. There is only one person that is making more than that 8,700. And in fact, the people, I guess not one person. These are percentages, right? These are, let's see, where is, oh, I'm reading the graph wrong. Those are the percentages across the top. The average 8,700 is, it looks like, percentage of households incomes across the bottom. So we have the same problem. We're just looking at it a little bit different. So here's $8,700. So you've got 3% of people that are making more than that. 3%, 2%, 2%, 1%, 1%, 10%. So if I add those together, that's what? 10, 14, 17, 19, 21, 22, 23, 24. So about 24% of people are making more than $8,700, okay, every month. But 76% of people are making less than that. So how is $8,700 the average household income? Because of these big numbers up here, right? You've got this high percentage, 10% of people, it looks like, are making $15,000 or more a month. And I would imagine that's because that more goes up really high. But that presents a false sense of information. It's telling you, it makes you feel like everybody is somewhere around $8,700. But when you look at the individual data, there's not a lot of people around $8,700. Those people that are making a lot of money are pulling that number up a lot higher, which makes the average not seem quite as legitimate. It doesn't seem like the average. But if I use the median is 6,300, which is right about here. If I use the median, oh, that wasn't a very good line, 6,300. Now all of a sudden you've got about half the percent on the left and half the percent on the right. So that's a little bit more accurate than going with the average. Which is why you use the median sometimes. When there's an outlier, it works a lot better to use the median because the median doesn't get skewed, doesn't get messed up by those outlying figures, all right? Okay, so homework. On this first measure of center page, there's like 7 just basic problems to practice finding mean, median, and mode. Make sure you remember how to do that. And then there are some more analytical questions on the homework page that you're going to have to think about a little bit more. You're still going to be finding the same values, but it's going to ask you to analyze those numbers a little bit more than it was in those first examples. All right. So if you need any help, come and visit with me. I'll see what I can do to help you out.